Welcome to MRL. In this learning session, we'll be learning the solutions of examples of end of chapter exercises of Ganith Manjari, third chapter, World of Numbers for 9th NCERT new syllabus. Now in the first example there we have, and again before I teach you the solutions or learn the solutions, I have divided this end of chapter exercises into two parts. So this is the part 1 of end of chapter exercises. I have divided the examples into two different parts, part 1 and part 2. So learn both the parts. In the first part here I have taken the first example. Now to find decimal expansions by long division method. Now long division means you should know, or I believe that you all know, how to divide fractions. If you have a doubt in division of fractions, then please go through my video on fundamental operations of numbers and also the study of fractions. There are separate videos on that in my channel. Please refer them, go through them, learn them, and then begin solving these or understanding the solutions of these examples. Now the first example is 3 by 50. As we know, 3 is not divisible by 50. Therefore I take a decimal point, I get 30. Still it is not divisible, I take a 0. Now it is 300 divided by 50. I get 15 to 6 is 300. Therefore 3 by 50 is 0.06, which is a terminating decimal expansion. Now this next example is 2 by 9. 2 divided by 9. 2 is smaller than 9, 2 is not divisible by 9, so I take 20 and I take a decimal point. Now when I continue dividing, I get 0.2 bar, that is 2 is repeating here, therefore it is a non-terminating and recurring decimal expansion. Now to prove that root 5 is irrational, so there are two ways of proving it. So let us understand the first method. In method 1, we have to find out the value of root 5 by long division method. Again, if you are not good in finding out the square roots of numbers, please go through the separate video which is made already and uploaded, and that on square roots. So please learn from that how to find out the square roots of what you call non-perfect squares, and there is a method for that, there is a procedure for that, that is the long division method. Learn that and then begin to learn the solutions of the end of chapter exercises here. That will be easy and very comfortable for you to understand the solutions. Now in the first method, find the decimal expansion of root 5, and the decimal expansion of root 5 by long division method is 2.23606 ... That means you find the decimal expansion is a non-terminating and non-recurring decimal expansion, and therefore root 5 is an irrational number. So that is by definition of irrational number, we know that any irrational number has a decimal expansion which is non-terminating and non-recurring, and therefore we find the root 5 has a decimal expansion which is non-terminating and non-recurring, and therefore root 5 is an irrational number. Now the second method is the contradiction method, which is given by Hippasus, as you already know that you learnt in the basics of your textbook. Now the method is very simple. What is this contradiction method? Contradiction method means assuming something to be true and proving that what we have assumed is incorrect, therefore what we have not assumed is correct. So that is what is the basis or the basics or the what you call principle of contradiction method. Now let us understand how it is applied here. Now let us first assume that root 5 be a rational number. So we are assuming it, mind you. Let root 5 be a rational number. If root 5 is a rational number, then root 5 can be written as p by q, because p by q is a rational number. Now if the p and q are not co-primes, rather they have other factors common between them, then we divide p and q such that we get cofactors, we get the co-primes a upon b. So we have got root 5 is equal to a upon b, where a and b are co-primes, rather a and b have a common factor as 1. Therefore the factors which are common to a and b is 1, and that is the first point. Now let us cross multiply it. Root 5 into b is equal to a. Squaring it, we get root 5b whole raised to square is equal to a square, or 5b square is equal to a square. Now if you find here that 5 is a factor of a square, because 5 divides a square here, therefore 5 is a factor of a square. If 5 is a factor of a square but natural, 5 is also a factor of a, and that is the second important statement. Now once 5 is a factor of 5 is a factor of a, that means any number multiple of 5 is also a factor of a square, and therefore replacing a by 5c, we get 5b square is equal to 5c square, or 25c square dividing, we get b square is equal to 5c square. Now from this we understand that 5 is also a factor of b square, that means 5 is also a factor of b, that means 5 is a factor of b also. That means we have found here in 2 5 is a factor of a, in 3 we have 5 is a factor of b. But this contradicts what we have learnt in first statement, that a and b have only factors as 1. Now this contradiction arisen, this contradiction has arisen because of the wrong assumption. This contradiction has arisen because of the wrong assumption that root 5 is rational, and therefore conclusion is that root 5 is an irrational number. So please remember this. So a very simple method, try to learn this. It's a very important contradiction method which you have to learn, and very much a question which can be asked in the examination. Now the third example is to convert decimal numbers into p by q form. Please remember this. Convert decimal numbers. You are given a decimal number, you have to convert it into p by q form. Now here 12.6 is a terminating decimal expansion, and you remove the decimal by dividing by 10, so it becomes 126 by 10, and the 126 by 10 is 100% a p by q form. If you want, you can simplify it by dividing it by 2, it becomes 63 by 5. Now the second example is 0.0120, again a terminating decimal expansion. Remove the decimal by putting the 0, that is 1 followed by zeros in the q in the denominator, and there are 4 places here, therefore 4 zeros taken. So 120 divided by 10,000, and if you simplify it, you get 3 by 250. 3 by 250 is the p by q form of 0.0120. Therefore conversion of terminating decimal expansion is very simple. Just remove the decimal and count the number of places and put so many zeros in the denominator, you will get the p by q form. Now the third example is 3.052 bar. Please understand, this is a very important example. 3.052 bar. It is a non-terminating recurring decimal expansion, definitely a rational number, but non-terminating recurring. But if you observe here that after the decimal point, repeating part is not starting. After the decimal point there is a non-repeating digit, and then the repeating part starts, and therefore this is called as impure terminating recurring decimal expansion, and therefore we have to first convert into pure form. To convert into pure form, make this 0 as an integer part. To do that, multiply x, assuming x is equal to 3.052 bar, multiply by 10 and we will get 10x. So this 0 gets shifted to the integer part, we get 30.52 bar. Now it has been converted into a pure form, that means the repeating part starts exactly after the decimal point. Now bring this 5 to the 5 2 also to the integer part. To do that, I have to multiply 10x by 100. So 10x into 100 is equal to 100 into 30.52 bar, and that is equal to 3052.52 bar. Now subtract the from this 1000x. So subtract 10x. When I subtract 10x from 1000x, I get 3052 minus 30, because 52 bar will get cancelled. So 3052 minus 30 becomes 3022. Therefore x is equal to 3022 divided by 990. Therefore the conversion of 3.052 bar is 3022 divided by 990. So please remember the important basic here. If it is a impure form of non-terminating recurring decimal expansion, you have to convert into pure first, and then start the calculations. Now let us take one more example. Now example number 4, we have 1.235 bar. It is 100% again impure, because there is a non-repeating part and then the repeating part starts here. So let us assume that x is equal to 1.235 bar. So move 2 to the integer part, that means it becomes 10x is equal to 12.35 bar, and again 35 you have to move towards the integer part. So multiply by 100, we get 100 into 10x is equal to 100 into 12.35 bar, that is 1000x is equal to 1235.35 bar. Now subtract 10x, subtract this 10x. Please subtract 10x from 1000x, we get 1000x minus 10x, and that is equal to 990x, and 0.35 bar gets cancelled, and 1235 minus 12 becomes 1223. Therefore x is equal to 1223 divided by 990, and therefore 1.235 bar is equal to 1223 divided by 990. A very simple method. You have to just practice it, understand it, and apply it. So therefore first important step is converting it into pure form, that is making the decimal point before bar 35. So take towards the integer part. So that is the basic thing which you have to remember. Now coming to 0.23 bar, this is pure form. So here you have to do nothing. Assume that x is equal to 0.23 bar. Now bring 23 to the integer part, multiply by 100 for that. So 100x is equal to 23.23 bar, and then now subtract x from 100x. So 100x minus x is equal to 23.23 bar minus 0.23 bar. 23 bar will cancel. We get 23, and therefore 99x is equal to 23. X is equal to 23 divided by 99, or you can further divide if it is possible, or just leave it as 23 by 99. Therefore 0.23 bar is 23 by 99. Now the sixth example is here, that is 2.05 bar. It is impure part again. So first multiply by 10x, so that you get 20.5 bar. Move 5 to the integer part. For that you have to multiply by again 10. So 10 into 10x becomes 100x, and it becomes 205.5 bar. Subtract 10x from 100x, it becomes 90x, and 5 bar will cancel. We get 205 minus 20. 205 minus 20 becomes 90x is equal to 185. X is equal to 185 by 90. If you want, you can simplify it or leave the value as it is, and therefore 2.05 bar is equal to 185 by 90. Now coming to the next example, 2.125 bar. We already learned this. Now let us go to the 8th example. Here the 8th example is okay, let me repeat the 7th example again. 2.125 bar. 2.125 bar is 100% impure decimal expansion. So therefore now first of all convert it into pure decimal expansion. There are two digits here in non-repeating part, and therefore take this 12 to the left. For that you have to multiply by 100. So 100x is equal to 212.5 bar. Now 5 you bring to the left by multiplying by 10. So 1000x becomes 2125.5 bar. Now subtract 100x from 1000x, we get 900x, and 2125 minus 212, because 5 bar cancels there. So 2125 minus 212 becomes 1913, and x is equal to 1913 divided by 900. So therefore the p by q form of 2.125 bar is equal to 1913 by 900. Remember that. Now the next example is 2.1625 bar. If you observe here, it's a pure form of the decimal expansion for a rational number. Now assuming x is equal to 2.1625 bar, move this 1625 to the integer part. So how many zeros you have to take? 1 2 3 4. So 1 followed by 4 0 into x is equal to 21625.1625 bar. Subtract x from 10,000x, and therefore we get 9,999x is equal to 21625 minus 2, because 1625 bar and 1625 bar will get cancelled, and therefore it is 21623 divided by 4 nines, and that is the value of x, and that is 2.1625 bar is equal to 21623 divided by 4 nines. So that is the conversion of the what you call decimal expansions. Now this is again a different type of example here, that is the 5th example. To find 6 rational numbers between 3 and 4. To find 6 rational numbers between 3 and 4. So we can find the 6 rational numbers by different methods. We have got the average method, we have got the denominator method, and also we have got the decimal numbers method. Now here I will adopt the denominator method. The denominator method is very, very simple, and for that what we have to do is take the values 3 and 4 and multiply it by 7. So when I multiply by 7, 3 into 7 divided by 7 becomes 21 by 7, and 4 into 7 by 7 is 28 by 7. Now I want 6 rational numbers here. Because I want 6, I have taken it as 7, 1 more than 6. So 3 into 7 by 7, 4 into 7 by 7, we get 21 by 7 and 28 by 7. And if you observe here, after 21 becomes 22, so 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7 are the required 6 rational numbers between the given numbers 3 and 4. So please remember In the denominator method, if the denominators are same, because the denominator of 3 and 4 is 1 and 1, so take 1 more than 6, that is 7, multiply by 7 in both the numerator and the denominator, get the new rational number, that is 21 by 7 and 28 by 7, and then write on the 6 required rational numbers between the two given rational numbers. So these are the 6 rational numbers between 3 and 4. Now to find 5 rational numbers between 2 by 5 and 3 by 5. So write 2 by 5 and 3 by 5 here. You find the denominator is same, absolutely no problem at all. Then add 1 to 5, that is 6, multiply by 6 in both numerator and denominators for both the rational numbers. You get 12 by 30 and 18 by 30. Between 12 by 30 and 18 by 30, we get 13 by 30, 14 by 30, 15 by 30, 16 by 30, 17 by 30, which are the 5 required rational numbers between 2 by 5 and 3 by 5, and a very easy example. Now coming to the next example, to find 5 rational numbers between 1 by 6 and 2 by 5. 1 by 6 and 2 by 5. If you observe here, the denominators are different. 6 and 5 denominators are different. The first step is make the denominator same. And for that you multiply by 5 and 5 for 1 by 6. And 2 by 5 should be multiplied by 6 and 6 in both numerator and denominator. We get 5 on the 5, 6 5 the 30, 6 to the 12, 6 5 the 30. So I have made the denominator same for both 1 by 6 and 2 by 5. Once you have made the denominator same, just see whether you can write the required 5 rational numbers or not, and here we can write, and therefore it will be 6 by 30, 7 by 30, 8 by 30, 9 by 30 and 10 by 30, and they are the required 5 rational numbers between 1 by 6 and 2 by 5. So the basic here is make the denominator same and then check whether you can write the required number of rational numbers between them. If you cannot write the required number of rational numbers, then you can multiply by any other number both in the numerator and the denominator to get the required number of rational numbers. Now the next example is, you are given x by 3 plus x by 5 is equal to 16 by 15. You have to find the value of x. So let us solve this. X by 3 plus x by 5 is equal to 16 by 15. Now find the LCM of 3, 5 and 15. LCM is 15. So multiply every rational number by 15 here. Multiply x by 3 by 15, x by 15, 16 by 15 by 15. And we see that 3 gets the 3, 1 the 3, 5 the 15, 5 1 the 5 is the 15, 15, 15 gets cancelled here. It will be 5x plus 3x is equal to 16. So please remember this, whenever there are denominators in rational numbers, try to eliminate the denominators so that the equation is eliminated of the denominators. So that is what I have done here. So I have got here 5x plus 3x is equal to 16. Add 5x and 3x, I get 8x is equal to 16. So x is equal to 16 by 8, and therefore x is equal to 2 is the answer. Now this is another important example. We are given a and b are rational. A plus 1 by b is equal to 0. So a and b are rationals, and a plus 1 by b is equal to 0. We have to prove that we have to find whether ab is positive or negative. So to find if ab is positive or negative. Now let us start with the condition given. A plus 1 by b is equal to 0. Taking or rather I can take 1 by b to the right. So a is equal to minus 1 by b. Or taking b to the left, by taking b to the left multiplication, so ab is equal to minus 1, but natural ab is negative because 1 is a negative number. Now minus, because 1 is minus 1, which is negative, and therefore ab is a negative number. Remember that. Now here we have been given 18 by 125. We have to find the type of decimal expansion and the number of decimal places also. Now to find out the type of decimal expansion, we can go by the factors method of Q. We can go by long division method also, but here we will go by factors of Q. Now 18 by 125, 125 is 5 cube. So the factors of Q, that is 5 cube is Q here, is of the form 5 raised to n. Whenever Q is of the form 2 raised to m, 5 raised to n, or 10 raised to p, or 2 raised to m into 5 raised to n, then it will have a terminating decimal expansion, and therefore 18 by 125 has terminating decimal expansion. That is first part. Now to find out the number of decimal places, it's very simple again. We have got 18 by 125, we have got 18 by 5 cube. Now convert this 5 cube into 10 cube. So now for that what I have to multiply is 2 cube, both in the numerator and the denominator. So it is 18 into 2 cube, 5 cube into 2 cube, 18 into 2 cube becomes 18 into 8, 5 cube into 2 cube becomes 10 cube, 18 into 8 becomes 144, 10 cube is 1000. So divide 144 by 1000, after 3 decimal places put a decimal point, so 0.144. So therefore the decimal expansion has 3 decimal places. So please remember that it has got 3 decimal places. Even without doing this, we know what is the power of 5 here. Power of 5 is 3, so therefore it has 3 decimal places. Remember that. Now coming to the next example, that is we are given p by q, and here q is 2 cube into 5, 2 raised to 3 into 5. Now first of all, let us understand what is the p by q form here. To find the p by q form, what we will do, we'll write down p by q form, that is 1 divided by 2 cube into 5, and if I have to convert it into 10 cube, I have to multiply by 5 square, so I have taken the numerator as 5 square. So ultimately we get the value of p by q is 1 by 40. So we know that p by q is 1 by 40, but the question is how many decimal places p by q will have. So for that, what I will do, 1 by 40 I will convert it into 25 by 10 cube. See, 25 by 10 cube here. So 25 by 10 cube is 25 by 1000, and therefore the value of 1 by 40 is 0.025. So 0.025 means there are 3 decimal places in the decimal expansion of 1 by 40 or p by q. Now otherwise also, what is the power of 2 here? 3. Therefore the maximum power is 3, whereas the power of 5 is 1. So if the maximum power is 3, the decimal expansion will have 3 decimal places. That is an easy method of finding out, or you can solve in the manner I have explained it to you. So please remember that. Now this is a very interesting example. Here we have been given a square root spiral. It is a square root spiral. Now this square root spiral is very much required, or we have to construct these right angled triangles in order to locate the root values, that is root 2, root 3, root 4, root 5, root 6, root 7, root 8, root 9, root 10, root 11 on a number line. Now we cannot find out the value of root 2, we have to geometrically construct and find out the value of root 2 and then locate that on a number line. For that, we have to construct right angle triangles on the number line and find the value of root 2 and then locate the value of root 2, which we already learnt in World of Numbers basics videos. So let us understand here. What he says is, find the lengths of the hypotenuses of all the right triangles in this figure. Now this is called as a square root spiral. Now let me explain this to you, and then again I will explain separately. Now we have a right angle triangle here. The base is 1 and the height is 1. So now if I apply the Pythagoras theorem, then it will be 1 square plus 1 square, that is 1 plus 1. 1 plus 1 will be square root of, so therefore the hypotenuse is square root of 2. Apply the Pythagoras theorem. Supposing if I take this triangle as ABC, then we have the AC, or rather a square plus b square is equal to c square. So 1 square is 1 and b square is 1. 1 plus 1 is 2, square root of 2. So this hypotenuse is square root of 2. Now if I have to find out this hypotenuse, then this is square root 2 square, 1 square. Square root 2 square is 2, 1 square is 1, 2 plus 1 is 3, this is square root 3. Now square root 3 square is 3, plus 1 is 4, this is square root of 4. Now square root of 4 square and 1, this will be 4 plus 1, so this is square root of 5. Similarly, this will be square root of 6, square root of 7, square root of 8, square root of 9, square root of 10 and square root of 11. So like that we can find out the measures of the irrational numbers to locate them on the number line. So now by knowing this length, that is root 2, I can use this length to locate root 2 on the number line. So also I can locate root 11 on the number line. So this is what is called as the square root spiral. So I have already we have already discussed to locate how to locate root 2 on a number line in our World of Numbers discussion, and you can go through that. But if you still want how to locate root 3, root 5, root 6, root 7, root 8, root 9, root 11 and all that, I will make a separate video for that. Now let us understand this by how to find it. Now to find the lengths of the hypotenuses of all the right triangles formed in the square root spiral. Now hypotenuse square is equal to a square plus b square. This is Pythagoras theorem. So you have to apply the Pythagoras theorem for each triangle. So if I take this as triangle 1, that is, this is triangle 1, then we can find out that triangle 1 hypotenuse square is equal to 1 square plus 1 square, that is 1 plus 1, and therefore 1 plus 1 is 2, and therefore h is equal to root 2, that is for triangle 1. For triangle 2, root 2, please understand here, for triangle 2, root 2 is one side and 1 is another side. So I have to take the hypotenuse square as root 2 square plus 1 square, so it will be 2 plus 1 and that is 3, therefore hypotenuse is root 3. And for the third triangle, I have to take root 3 as one side, so root 3 square plus 1 square, 3 plus 1 is 4, and h is, or hypotenuse is 2. So also triangle 4, 4, 2 square plus 1 square, 4 plus 1 is 5, h is equal to root 5. For triangle 6, it will be root 5 square is 5 plus 1, that is 6, therefore h is equal to root 6. For similarly, for triangle 7, it is root 7, 8 is root 8, 9 is root 9, that is 3, and we have got root 10, root 11, and that is what is the procedure of finding out the hypotenuses of the right angle triangles of the square root spiral. So please remember this and learn this. So therefore remember, the lengths of hypotenuses which we have found out can be used as a measure to locate the irrational numbers on the number line, which we have already learnt. But still, if you want to learn the further locations of root 3, root 5, root 6, root 7, root 10 and so on, I'll make a separate video on that for discussion. Okay, so this is what is the first part of the exercise, end of the chapter exercises, which you have to learn, understand, and write down in a book for your future reference. Okay, so let us go to the second part in our next video. Okay, thank you.